Hi everybody, we're going to solve this rational equation. I need you to go ahead and start with a fresh sheet of paper if you're writing with me and write. So we're going to skip lines and really use space up on our page. It's important that we do give ourselves space to work these problems out so that we can see how it plays out on paper. Okay, so we're solving the rational equation 4 over s minus 2 plus 4 over s plus 2 is equal to 5/6. Now, if you look at this, our LCM of the denominators, here's our denominators, okay, is actually going to be the 6 times the s minus 2 times s plus 2. So we have 3 different factors in our common denominator. Now, if you're just tuning in with common denominators, we are not actually going to put everything over the common denominator. We're going to take this common denominator and distribute it into the entire equation. So if you look here, you'll see that we have 1, 2, 3 terms on both sides of our equal sign. For this first one is I'm just going to kind of draw a fraction bar. Already I have a 4 in this numerator. I'm not going to multiply it up yet. And already in that denominator I have s minus 2. So you can see I'm just kind of folding it in using my multiplication. Now this plus sign, right? This is plus. And we're going to do the same thing with the second term of 4 over s plus 2. We'll multiply that 4 that's already in our numerator, and we already have an s plus 2 in our denominator. And notice I'm just kind of encapsulating those binomials in the denominator with some parentheses. Now over there on the right side of our equation, we have this 5 over 6. I'm going to do the same thing. Everything over that 6. Now let's see what happens with cancellations. This is going to become much nicer looking, right? This is probably the ugliest step you have to write, and it's important to write this out so that you can keep track of your cancellations, right? Remember, a binomial over itself cancels to 1. Okay, we'll come back and multiply the other stuff later. Let's just go through and see what cancels. On the second term, s plus 2 is what's going to cancel. And in the last one, on the other side of the equal sign, those 6's do cancel. So we'll have 4 times 6. That's 24. And s plus 2, we're going to take as many steps as we need to see this multiply out. So let's just go through simply. Multiply just your numbers. 24, s minus 2, that's what's left over. We're going to come back through and multiply, don't panic. And then we have our 5. And we have s minus 2, s plus 2. Okay, now let's go ahead and make this even nicer looking. We're going to just distribute these 24s carefully. Watch your signs. Times s, right? 24 times a positive 2, positive 48. Okay, 24s again, plus 24s, right? 24 times negative 2 is going to give us a negative 48. Now over here on the right side, what I'm going to do is I'm going to go ahead and take care of this first, right? S minus 2, s plus 2 is going to be what? FOIL, right? S squared. Look at that. It's the difference of 2 squares, right? Those inner terms cancel, and you end up with a minus 4. So that worked out very nicely, okay? So let's go ahead and get that. Put that right back in here where it goes. Okay, so what I'm going to do next is just carry this down. I'm going to distribute the 5. Okay, and we'll have 5 s squareds. And then 5 times negative 4 is minus 20. Now, every time you distribute, you always want to do what? You want to combine like terms. So let's go through and we'll combine the like terms in this step and we'll see what we get now. Now we do have 24s plus another 24s. That's 48 s's. But there you go, 48 minus 48 cancels, right? That's 0. And then we have is equal to 5s squared and the minus 20. Now, what is this? This is a quadratic equation now. So help us to get everything on one side. And since my leading coefficient is positive on the right side, I'm going to go ahead and move everything over there. So let's subtract 48s from both sides. And no, there's nothing to subtract it from on the right, but we're going to fit it in descending order. And we'll see what we have. So we have this 5s squared minus 48s minus 20. All right, so where do we go from here? Let's have a good look at this. We cannot factor out any common monomial factors, right? 5, 48, and 20, although it looks tempting, right? We cannot factor anything out to the front. We can use the AC method. Remember that? Remember factoring? Okay, where we say, okay, what's 5 times negative 20? That's negative 100, right? So we want the factors of negative 100 that would add up or subtract to give us the negative 48. Let's have a look. Negative 100. Well, right away you can kind of see that we have 2 times 50, right? So which one can be negative? So let's see, if the 2 is negative, right? If that happens, then 50 minus 2 is positive 48. Didn't work out. So if we have a negative 50, right? So 2 times negative 50 would give me the negative 100, the AC. But I have negative 50 plus 2, that would give me the negative 48, right? In the middle. So let's factor this trinomial, see what happens from there. So we will bring down the 0, open our 2 sets of parentheses, right? Now, the cool thing, 5, you can either have 5s and s, right? So that starts you off. Now, one of these has to be 50, one of them has to be 2, right? So we have to have maybe 50 where the 5 is, right? Actually, it's going to be negative 50. And over here, we'll have our 2s, right? 5 times a negative 10, right, would give me the negative 50s. I'm going to make that look nicer in a second. And then the 2s here. So if we want a positive 2s, we can put our plus here, right? And let me scoot that minus 10 in a little closer. So minus 10. Of course, let's go ahead and erase our little drawings here and just check it, right? 5s times s gives me the 5s squared. All right, we have a negative 50s, right? And then we have our plus 2s. That gives us the negative 48s. And then last, positive 2 times negative 10 gives me my negative 20. Remember, always check your factorizations by multiplying it back up, right? Okay, so that's really cool. So now we just have to find the solutions to these individual factors. So now 5s plus 2 can be 0, right? Because we have our 0 factor property. Okay, or s minus 10 can be 0. So we'll solve each of these independently. So subtract 2, right? 5s is equal to negative 2. Divide by 5 on both sides. And now s is equal to negative 2/5 for this side. Or, here we go, add 10, and we can have s can equal 10 right here. Now, remember when you solve rational equations, you want to go back and make sure you don't have an extraneous solution. In other words, you want to go back to the original equation and make sure that none of the denominators, in this case, the denominators are not going to zero out, right? Because when we have a 0 denominator, that's a problem, right? That makes it undefined. Well, we can see that negative 2/5 is not going to cause it to be undefined, and neither will 10, right? If we plug a 10 in, it's just going to be, what, 8 or 12 in the denominator. So actually, both of these solutions work out